Welcome to the fifth part of Module 4 Stereochemistry. Now in this part we will be looking at how we can name optical isomers. Now we move on to the RS system of nomenclature. Now in case of optical isomers, when there are a large number of isomers, it is difficult to give proper naming to them. Dextro, levo, meso, etc. It is very difficult. So in that case, we have to opt for some other method for naming these compounds. And the RS system of nomenclature is a very convenient one. Here R stands for rectus and S stands for sinister, meaning right and left respectively. Now this system is very much similar to the EZ system, where you have to assign priority to the different groups. So the rules are the same as in the case of EZ system. Lactic acid, because lactic acid contains only one chiral carbon, so it is very easy to understand the R and S system using lactic acid. So this is the structure of Fischer projection of lactic acid. There are four groups here: the OH, the COOH, the OH, COOH, CH3, and the hydrogen. This is the central carbon. Now these four groups have to be assigned priorities based on the rules, certain rules. The rules are the same as in the EZ system. So the first rule, the atomic number of the atoms directly connected to the asymmetric carbon are considered, and the priority is assigned in the descending order of atomic number. That is, greater the atomic number, higher will be the priority. So let us start with this compound. So lactic acid, now there are four groups here: OH, COH, H and CH3. Out of this, oxygen has the maximum atomic number. So this OH group, that gets the first priority. Now here, if you look at these two groups, the atoms attached to the central carbon are the same. They are carbon, and so we have to follow the second and the third rules to assign priority to COOH and CH3 groups respectively. And what are the second and third rules? The second rule is, if the atoms directly attached to the asymmetric carbon are same, then the atomic numbers of second atoms are considered, and if they are also same, third atoms are considered, and so on. And the third rule, multiple bonds are taken as separate single bonds. So based on these rules, so OH has first priority anyway, COOH and CH3. Let us look at this. COOH, C, carbon is connected to oxygen, a double bond oxygen and single bond oxygen. So there are three oxygen single bonds. Double bond is equivalent to two single bonds, and so you can assume that this carbon is connected to three oxygens. Here this carbon is connected to three hydrogens. So the total atomic number, if you take here, it is 24, oxygen into 3, and here it is 3. So this group COOH has more priority compared to CH3. So COOH has second priority, CH3 has third priority, and hydrogen, that has the least atomic number, and that has priority 4. After assigning priority, the molecule is viewed from a direction behind the least priority group. So that is one important thing. After we assign the priorities, we view the molecule from behind the least priority group, and then we move from the priority groups 1 to 2 to 3. Okay, and in this movement we check the direction, whether it is clockwise or anti-clockwise. Okay, so these are the two things that we are going to do. We have assigned the priorities. Now we are viewing the molecule from a direction behind the least priority group, and then we move from priority 1 to 2 to 3, and we check the direction of motion, or we note the direction of motion when we move from 1 to 3, whether it is clockwise or whether it is anti-clockwise. So here again you have the molecule, you have the different priorities. You are viewing the molecule from behind the fourth priority or the least priority group, and in this movement, so 1 2 3, you have to move from the first to second to third priority, and you have to check whether this is clockwise or anti-clockwise. Now if the least priority group is in the vertical line, then the movement clockwise will be R and anti-clockwise will be S. So suppose that the least priority group is in the vertical line, then movement from 1 to 2 to 3 will be, or if the movement from 1 to 3 is clockwise, the naming is R, and if it is anti-clockwise, the naming is S. But if the least priority group is in the horizontal line, then the opposite is followed. That is 1, 2, 3 priority group movement anti-clockwise will be R and clockwise will be S. So depending on the position of the least priority group, when the least priority group is vertical, 1, 2, 3 clockwise is R, anti-clockwise is S. When the least priority group is horizontal, 1, 2, 3 anti-clockwise is R and clockwise is just the opposite of this one. Okay, just the opposite of this one. Now let us go back to the lactic acid. This is plus lactic acid that we were looking on. We have assigned the priorities 1, 2, 3, 4. We are viewing from a direction behind the least priority group, and we are moving from the first to the second to the third priority. So this movement, the least priority group is the horizontal position, and we are moving from 1 to 3. This movement is anti-clockwise. Okay, so least priority horizontal means anti-clockwise is R. So the naming of this compound is R lactic acid. Okay, R lactic acid. Now let us see another example. This is L lactic acid. Okay, this is minus lactic acid, levorotatory lactic acid. Now here again we are naming the groups. 1, this is 1, this is 2, this is 3, and this is 4. We are viewing from a direction behind the least priority group, and then we are moving from 1 to 2 to 3. So that movement is clockwise. Okay, this movement is clockwise. Least priority group is horizontal. This movement is clockwise. So horizontal clockwise means it is S. The notation is S. So this compound is S lactic acid. Okay. Let us take another example. This is amino lactic acid. Okay, amino lactic acid. Now this is the central carbon. There are 4 groups attached. So we have to assign priorities based on the atomic number. Oxygen has more priority. So this is 1. Nitrogen, that has next priority next atomic number. So that is 2. And you have COOH and CH3. So both are same, and so the second atoms are considered. You have double bond oxygen and single bond oxygen here, so equivalent to 3 oxygens. Here it is 3 hydrogens. So COOH has more priority 3, and this is priority 4. So 1, 2, 3 and 4, these are the priorities. View the molecule from a direction behind the least priority group. So you are viewing from this direction, and then you move from 1, 2 to 3. So from 1 to 2 and 2 to 3. So that the least priority group is vertical. Movement from 1 to 3, that is clockwise. So clockwise, vertical clockwise means the designation will be R. This is R amino lactic acid. Another example, let us take the isomer of this compound. This is the isomer. Again, assign priorities. So priority 1, priority 2, again priority 3, priority 4. View from a direction behind the least priority group. Least priority group is vertical, and when we move from 1 to 2 to 3, that movement is anti-clockwise. So vertical anti-clockwise, the designation will be S. So this compound is S-amino lactic acid. So this is how you are giving, you are assigning the R and S naming for optical isomers. If the compound contains two chiral carbon atoms, now when the number of carbon atoms increases, okay, the complication also increases. Example, tartaric acid contains two carbon atoms. In that case, the naming should be given for both the carbons separately. That is the let us take this structure. This is lactic acid, sorry, tartaric acid, and this is the second carbon, and this is the third carbon. So for second and third carbon separately, we have to give the namings. Okay, so when we consider the second carbon atom, in that case, this entire group is considered as a single group. All these functional groups are taken as a single group, and when we consider the third carbon atom, this entire thing is taken as a single group. Let us see the example first. Now I have done the same structure. So first we will assign the RS nomenclature for the second carbon atom, and then we will do it for the third carbon atom. So this is the second carbon atom. Now in the second carbon atom, these are the four groups. One is OH, one is COOH, one is H, and this entire thing is taken as a single group. Okay, so CHOH CH3, that is taken as a single group. So let us assign priorities. First priority evidently will go to this one because oxygen has highest atomic number. So first priority goes to OH group, and then second priority here goes to here. Now here you can see this is carbon, this is carbon. So both are same. So you have to look at the next groups. This carbon is connected to oxygen, carbon and hydrogen, but this carbon is connected to double bond oxygen and single bond oxygen. So that is equivalent to 3 oxygens. Okay, 3 oxygens means total atomic number is 24. Here the total atomic number is 14 plus 1 15. So this has higher atomic number, therefore the COOH group gets higher priority. 2, this entire group has priority 3, and the fourth priority goes to the hydrogen. Now view the molecule from behind the fourth priority group. The fourth priority group is horizontal, and then you move from 1, 2, 3. So when we move from 1, 2, 3, the movement is anti-clockwise, like this, anti-clockwise. But the fourth priority is horizontal, so anti-clockwise means it is R. So you have to write like this, 2R. 2 represents the carbon atom. The second carbon atom we are considering, so that is represented by this 2. So 2R. Okay. Now next is the third carbon. We have to name the third carbon. So this is the third carbon. These are the different groups: OH, CH3, H, and this entire group, that is CHOH, COOH. That is taken as a single group. Now let us give the priorities. So oxygen, that has more atomic number, so OH has priority 1. Now here there is a carbon, here there is a carbon. This carbon is connected to oxygen, carbon and hydrogen. Here this carbon is connected to 3 hydrogens. So total atomic number is more for this whole group. So this gets priority 2. CH3 has priority 3 and hydrogen has priority 4. Now you view the molecule from behind the fourth priority group, and then you move from 1 to 2 to 3. So 1, 2, 3 motion. That 1, 2, 3 motion, that is clockwise. Okay, clockwise. But least priority is horizontal. So clockwise means the naming will be S. So this is the naming of this compound. that is lactic acid 2R3S. Okay, this compound has a naming 2R3S. Again, let us take another isomer of lactic acid. This is the meso form of lactic acid. Let us try what happens with this isomer. So here you can see the OH is on the same side. This is carbon atom 2. Let us give the naming for carbon atom 2. OH has first priority. Second priority is for COOH because it is connected to 3 oxygens. Double bond O, single bond O. Third priority is for this group. This is 1 oxygen, 1 carbon and 1 hydrogen. And fourth priority is for hydrogen. View the molecule from behind the fourth priority group and then move from 1 to 3. So 1, 2, 3 movement is again anti-clockwise. So anti-clockwise with horizontal least priority. That means the naming is R. So you have 2R. The next compound, the same compound, the next carbon atom 3. So carbon atom 3, these are the 4 groups, OH, CH3, H and this group. So give the priorities. This is priority 1, this is priority 2 and this is priority 3, this is priority 4. View from behind the fourth priority group, move from 1 to 3, 1, 2, 3. So that is again anti-clockwise. So anti-clockwise horizontal least priority, that is also R. So this compound has the name 2R3R. Now let us consider another compound, the diamino derivative 2,3-diamino tartaric acid. Okay, so in this compound what will be the naming? So the carbon atoms 2 and you give the priorities. So priority is 1, nitrogen has atomic number 7, so priority is 2. Now in these two cases, here there are 3 oxygens, so priority is 3. This case 1 oxygen, 1 nitrogen, 1 carbon, so priority is 4. View from behind this group, this entire group, and this fourth priority group is in the vertical position. Move from 1 to 3, that is clockwise, and so the naming will be R, 2R. Now the third carbon atom, do the same thing, give the priorities. OH 1, amino is 2, this group will have priority 3 and CH3 has priority 4. View from behind this fourth priority group, move from 1 to 2 to 3, that is also again clockwise, and that is naming will be 3R. So this compound has a name 2R, 3R. Next compound, this is another derivative, that is the D form of diamino tartaric acid. Again start with the second carbon, give the priorities 1, 2, 3, 4. These are the priorities, and you are moving from 1 to 2 to 3 and viewing from behind the fourth priority. This movement is clockwise and the least priority is vertical, so it is again R, 2R. Next case, third carbon, give priorities, priority 1, priority 2, priority 3, this is priority 4. View from behind the least priority and move from 1 to 2 to 3. So the movement is anti-clockwise and the least priority is vertical, so anti-clockwise will be S. So this compound is 3S. So this is how we can assign R and S notation to the different optical isomers. R and S stands for rectus and sinister. Rectus means right, sinister means left. So if first you have to assign priorities to the different groups, and then you have to move from the first to the third priority, and if this movement is clockwise and if this movement is anti-clockwise, depending on that the naming will change, and also the naming depends on whether the least priority group is vertical or the least priority group is horizontal. So this is the RS system of naming.